In a global industry where anything can happen, where mistakes cost much more than dollars, we bring you expertise from around the world to ensure that everyone goes home safe every day. The internationally acclaimed Oil and Gas HSE podcast starts now with your host, Russell Stewart.
Hey everybody, thanks for tuning in to another episode of the internationally acclaimed OGGN HSE podcast, sponsored by KnowledgeVine, the leader in human performance improvement training and technologies. KnowledgeVine is committed to reducing the frequency and severity of workplace errors by helping organizations leverage technology to easily create a sustainable safety culture. KnowledgeVine, the evolution of human performance. Learn more at knowledgevine.com. Today, my guest on the show is Arvind Ravikumar. Did my Texas accent get that right, Arvind?
No, that was great.
I can tell from your accent that you're obviously a native Texan.
Yeah.
So tell us where you're from, Arvind.
I grew up in India and I did a lot of my education in engineering in New Jersey. One of the most interesting aspects of what I do in the oil and gas world is that I was not trained in the oil and gas world. I came to it through my training in electrical engineering, thinking about sensors and emissions from oil and gas supply chains. And now I'm working full-time on thinking about how do we reduce emissions associated with oil and gas operations.
Okay, and so you're on the faculty, and the reason I said Texas, because you're actually in Austin right now where we're talking from, right?
That's right.
And you are on the faculty at UT Austin's Petroleum and Geosystems Engineering Department.
Yes, that's right.
And so I didn't know this, and I think maybe our audience might really be interested in knowing this, and that's why we have guests on like you. There's something called the TOP, capital T, capital P, the Top Energy Training Consortium. That's the University of Texas at Austin, Penn State University, and Colorado School of Mines. And this consortium has put together an oil and gas inspector training program called TOPCORP, and it's received some awards for the system that they have. The award-winning program combines classroom instruction and field experiences with an online training course, and through funding and in-kind support, the program is offered at no cost to many federal and state regulatory agency personnel. Tell us some more about that, Arvind.
Sure. So the TOPCORP, what it really does is it's a comprehensive training program for state and federal regulators, field inspectors, policymakers, to really understand the advances in technologies that are being employed in unconventional shale oil and gas operations. And to give a bit of history around this topic, the TOPCORP program was originally started about a decade ago in 2012 with a collaboration between, as you mentioned, UT Austin, Penn State, and Colorado School of Mines, some of the top schools with petroleum engineering degree programs in the country. And the reason it was started was that around the time in 2012, there was a surge in shale gas operations, unconventional resources around the country, and there was not a lot of training available for the industry to be able to hire the people they needed around that time. And so what happened was the three universities got together and we decided, let's develop a training program to provide the practical skills necessary for people to work in this new area, unconventional resources around that time. And so we started training field inspectors, personnel from oil and gas companies, even policymakers, to understand the different technologies that are used in unconventional shale operations, as well as technologies that are now being used to monitor these operations, to look for methane emissions from these operations. So that training has grown and evolved over the past decade. And right now, we have this flagship training program, training courses, where we have people from state regulatory agencies, from the oil and gas industry, and from other consulting companies who regularly attend this training that we provide through the three universities. One of the most recent additions, and that I'm very excited about and involved in, is to think about how the most recent advances in addressing methane emissions from oil and gas operations is sort of permeating the industry as well as the regulatory side of this issue. What we've been seeing is a significant growth in innovation and new technologies that are being deployed across the supply chain. So not just production sites, but midstream compressor stations, liquefaction terminals, and pipelines. And there's a great need for a lot of people in the industry, for technology companies, and for regulators to understand what these new technologies are, how they work, and how can they bring down the costs of emissions reductions from oil and gas operations. And so that's sort of the newest addition to this TOPCORP training, and that's something everyone's excited about.
Well, that sounds great. There's a wealth of information on the website. Folks have even got downloadable equations for drilling and production and petrophysics and reservoir engineering and thermofluids. And there's over 30 plus webinars on the website. I'm looking at the most recent one here, or one of the most recent ones here. Integration of CO2 capture and conversion for carbon utilization and storage. But I'm seeing here back in July, Arvind, you were one of the webinar presenters. It was entitled The Net Zero Initiative for Decarbonization Pathways in the Oil and Gas Sector, and that was a panel discussion. You've been working on this methane for a long time. I see all the way back to December of 2021, you had a webinar on surviving the energy transition, methane emissions mitigation in the oil and gas sector. And not sure when this podcast will actually go live, probably, though, in the next 2 to 3 weeks. But as we record today, the long-awaited rules or regulations or proposals, policies from the EPA about methane emissions, that just came out this morning, didn't it, Arvind?
Absolutely.
So I just actually listened to a presentation yesterday from Energy Workforce, and they were talking about, what's called this, they call it IRA, it's called the Inflation Reduction Act. It's amazing what they can call something and then all the stuff that can be in a bill. But there's a lot of stuff in there about oil and gas and about renewable energies, and there's a whole big section in there about methane and penalties if you don't meet certain requirements and that sort of thing. One of the things that I was told yesterday in the presentation was they were waiting to see what these EPA proposals were going to be. So since they just came out this morning, you want to talk about that, Arvind?
Yeah, absolutely. So let me give a bit of a background. So with so much interest in oil and gas operations and emissions associated with oil and gas, what we've all realized is that, addressing methane emissions from oil and gas operations could be one of the most cost-effective ways to improve the sustainability of our oil and gas industry. The industry recognizes that, the government recognizes that, and experts in academia and other places also recognize that. What has been interesting over the past, not even 10 years, maybe just 5 years, there's been an explosion in the number of technologies and startup companies that have developed around this problem of finding methane emissions quickly and effectively. So let me back up a little bit and tell you what the biggest problems are. So the first problem is that methane emissions are random in space and time. You don't know when they occur, and you don't know how big they will be when they occur. So there are known methane emissions at your oil and gas facilities, things like pneumatic systems, things like known emission releases. All of these can already be addressed by operations. But the other big issue is that there are unknown methane emissions. These are methane emissions that come from leaks, that come from abnormal operations, such as an unlit flare. And these things are not predictable. We don't know when they will occur, and we don't know where they will occur. And if you look at the hundreds of thousands of wells and the millions of miles of pipelines, it becomes a real logistical challenge to be able to inspect all of this infrastructure and find out where the methane leaks are and fix them. So that was the biggest problem in being able to address this problem cost effectively. The second biggest problem is that there are a lot of methane leaks in our oil and gas infrastructure, but the biggest leaks, let's say you take the top 5% of the leaks from our oil and gas infrastructure, they contribute to over 50% of the problem. And so what this means is if you can solve the 5% of the leaks that are large leaks, you have solved 50% of the problem. That's a great thing because you don't have to worry about the rest of the 95% of leaks in your system. You just fix the top 5%. The problem has been is that because it's top 5%, they are very few in number and they happen infrequently. Finding them and monitoring your facilities constantly to detect when such a large emission occurs is challenging and it's expensive. And what has happened in the past 5 years is that has changed quite a bit because of this new technologies that have been developed. If you look up any news website, New York Times or Washington Post or Fox News, and type methane in the search bar, you will get a number of articles about technologies finding methane leaks. And this is an example of what new technologies can do. And when I say new technologies, until about 2010 or so, the only way oil and gas operators can find methane leaks is that they literally walk around the site, their facility, with a handheld camera on their hand and look for leaks. It worked, it was fine, but it's slow and it's very expensive because you constantly need two people walking around the site looking for leaks, and they have to do it across all facilities. But what has now happened is that we now have new technologies. So we have sensors that are put on drones, sensors that are put on planes, and even satellites that can detect and monitor methane emissions. And what has that done is two things. The first one is speed. It has now significantly increased how fast you can look for your leaks across your facilities. I'll give an example, right? A two-man crew walking around facilities looking for leaks can do about 5 sites a day. A plane outfitted with the sensors can do about 200 sites a day. So that significantly reduces your cost of methane monitoring. And the best part is, and which is why I like working in this field, is that the industry has been ahead of the EPA and regulations in this case. Colorado has always been a leader, and the regulatory agency and the industry have had a very good working relationship in Colorado. And what you're seeing here right now is that many companies in the oil and gas industry have already started deploying them because it's cheaper, and they just didn't wait for EPA to develop new regulations to address methane. They just went ahead and started using these new technologies like aerial systems, like drones, like satellites. And what you're seeing in today's methane proposal is sort of a formalization of what the industry has already been doing. They've been asking the EPA for a long time to allow them to use these new technologies, and what the new regulation that came out today reflects that.
So prior to that, that's one of the, besides our major theme on this show, which is everybody comes home safe, we're strong advocates for the oil and gas industry, and we believe when you're talking about the environment, the oil and gas industry is not the problem with the environment. They're going to be the solution to it. And what you just said illustrates what I believe, which is the oil and gas industry is so innovative. Yeah, they're going to find ways to make our environment better because they're going to find ways to do it profitably. And so to institute these technologies and replace the inefficiencies of, like you said, people walking around with a camera, that's just another example of the oil and gas industry and its innovation and its contribution to society, which it doesn't always get its just due. And so you're saying prior to this, the EPA was actually dragging its feet on this?
Yes, and partly because we didn't know much about these new technologies. We knew that they were out there, but they have not been tested. We didn't know if it would work. In fact, if you talk to the oil and gas industry, they were trying to do the same thing. They were trying a bunch of different technologies. Right now, we are involved with several companies on projects doing exactly that, testing 5 or 6 technologies to figure out which one would be most effective, most cost effective, and most appropriate for an operator and for a given facility. And I think it has taken some time over the past 5 years or so. The Department of Energy funded millions of dollars in testing these technologies, making sure that we know that these technologies work and that they're actually cost effective. And what you're seeing today is the culmination of the past 5 years of academic research, academic industry collaborations, and industry's own pilot projects that have evaluated these technologies, and some of them have come out doing really well, and that has been now formalized in this. So you're absolutely right. Until now, it would have been very difficult for an operator to use new technologies in their facilities, but that has changed right this morning.
Interesting. And so the TOP program has been integral in helping these companies gather and test and put all this new technology stuff together, huh?
Right. And it's not just the technologies in the industry. This is also a learning process for state regulators. They have also been observing these new technologies, and it's relatively new to them as well. So part of what we did through the Top Energy Training Program is to have introductory classes and training programs about these new technologies. How should regulators think about them? What are the most effective uses of different technologies? In fact, in my own research, we developed this model called FEAST. What the FEAST model does is it compares the performance of different technologies on a given set of operations. So we work with industry to use those models so they can decide which technology they want to use. there are like 30 or 40 choices available to every company. And if you have to try out every technology with a pilot demonstration, that becomes time consuming and expensive. So what our feast model does is it helps them model their operations and then simulate how different technologies will work for those operations and then choose the right technology. In fact, the EPA regulations that came out this morning used our model to demonstrate that this is exactly how you can use new technologies and you can get them approved by the EPA. So there's a lot of excitement around new technologies. I mean, if in this field, just over the past 5 years, there's been so much growth in these technologies that the bottleneck is not companies not wanting to find and fix methane emissions. It's actually the availability of these technologies to do the surveys because there's been so much demand. And with the EPA rule that came out today, I can only expect that this industry, this methane measurement industry, is going to grow significantly in the next decade.
Well, that's exciting. I had no idea. The fact that you're working with the regulators and we're trying to come together on this, that really is encouraging to me. I'm really glad to have found out about this program, and I'm glad to be able to share it with our audience. Arvind, are you on LinkedIn?
Yes, I am.
Okay, so we're going to put in the show notes, we're going to put your LinkedIn URL. Well, I will figure out, or I'll get you to help me figure out the best website address to put in there where you can get to these webinars that I talked about. And for you engineers out there, all those downloadable equations, if you're looking for a great little spot to, and I know you can Google those, but they've done a real good job of putting those together inside their website. Arvind, I really appreciate you coming on the show. I'm really excited to hear about this. And for people listening, reach out to Arvind if you want to get involved in this, if you want to know more about it. Anything else you want to say, Arvind, before we sign off here?
No, I think that's good. I think we covered all the important parts.
Okay. It was just the introduction to what you guys are doing and finding out how the EPA's new regulations are going to complement all this new technology. That's very exciting.